Alright, so in this video, we'll be looking at the mean value theorem. So let's first talk about it in more of a mathematical sense, right, or a formal mathematical way, and then let's see if we can't make more sense, speaking more colloquially. And really, the mean value theorem is describing something that isn't very complex to understand. But speaking mathematically, if we have a function f, so if we have a function, if there's a function f that is continuous, it's continuous over a defined interval, right? So we have these square brackets within this defined interval a to b, and it's also differentiable in this interval and is differentiable on this interval of a to b. Right here again, we're not seeing if the exact points, those two endpoints are differentiable. So these are circular brackets here. Then there is a point C in this interval where the instantaneous rate of change equals the average rate of change over the interval. Average rate of change over the interval. So what is this trying to say here? So we have some function f that's continuous between these two defined points, and it's also differentiable between that same interval. That means in that interval there is some point c where the slope of the function, the instantaneous rate of change, the slope of the function at that one point c equals the average rate of change over this interval of a to b. So hopefully you've noted this down, and so let me just get rid of this now just to make some space so we can look at a graph and so you can make a bit more sense in case it isn't already. So let's say that we're looking at the graph of some function. So let's just draw an x and a y axis real quick. Y-axis, x-axis. So exactly, the graph of the function itself isn't too important here, but if we have some function like this, for example, we're looking at some function that looks like this. And now we're trying to, let's say we define two points along this function, right? We call this over here, this is our a. And then over here, this is b. So we have this interval of this function f, a to b. And so basically, if we draw you know what, let's make b this point over here. So if we make b this point here, then, again, it doesn't really matter, but if we then draw a secant line, right? We draw a secant line, a line going through these 2 points, a and b. Yeah, something like that. This secant line, right? This is the average rate of change. This is the average slope over this interval of a to b. Right, we understand what that means. And so basically what the mean value theorem is saying is that in between this interval of a to b, there's going to be some point c whose slope, or the slope of the function at that point, is actually going to equal this average rate of change. Right? We know that this average rate of change is not very precise. We can see that the function has a variable slope, right? Which is why we use things like derivatives in order to figure out the slope of this function at any point along this curve. And so what the mean value theorem is saying is that some point on this interval, the slope is actually going to be equal to the slope of the secant line here. So if we choose some point c, let's say that this is c, right? This looks about right? Or maybe over here. If we say this is C, we can see that if we draw a tangent line, that tangent line is about parallel. It's going to be parallel to the secant line, right? So if we say that this is our C right here, basically at this point on this interval of a to b, the slope is actually the same as this, the slope of our secant line, or the average rate of change. So that's all the mean value theorem is saying. It's saying that if we have this defined interval for some continuous differentiable function f, then there's going to be a point C in this interval where the slope, the instantaneous rate of change at that point, is going to be equal to the average rate of change across this interval. That's all it's saying. So hopefully that makes some sense. Again, it is describing something that is rather intuitive. It's nothing too crazy here, but it's important that you do understand what it is we're talking about. So just guess if you wanted to write it quickly as an expression, and we're saying that the derivative at the point C, right, the slope at f of C is going to be equal to f of B minus f of A over B minus A. This is our just a formula for our slope. So this is an A. So this is all this is describing. Our derivative f prime of C is going to equal f of B minus f of A over B minus A. This point C is going to exist along this interval at some point, is all we're talking about here. All right, so what does a problem using or involving mean value theorem look like? So let's say that we're having a function f of x that's equal to x squared plus 4x. Here, let me rewrite this. So let's say we have this function f of x is x squared plus 4x plus 5. And basically, we're trying to find, for example, on the interval from 2 to 6, right, what is the average rate of change? And then on that interval, when does the instantaneous rate of change equal the average rate of change? Right, is basically what we're doing with mean value theorem. So first, what is the average rate of change across this interval 2 to 6 for this function? Well, we know we can find the average rate of change by doing the f of b minus f of a over b minus a. So in this case, that's just f of 6 minus f of 2 over 6 minus 2. So here, our f of 6, right, we know how to do this. We just need to substitute. So we just get 6 squared, which is 36, plus 24, plus 5, minus 2 squared is 4, plus 8, plus 5, divided by 6 minus 2 is 4. So 36 plus 24 is 60, plus 5 is 65, minus 4 plus 8 is 12, plus 5 is 17, divided by 4. 65 minus 17, that's 48. 48 by 4 is equal to 12. So the average rate of change of this function between the interval of 2 and 6 is 12. So the slope of this function, there's the average slope of our function f of x is 12. Our function f of x has an average slope of 12 over the interval of 2 to 6. All of which are just saying the same exact thing. So now that we have this average rate of change, the average rate of change is equal to 12. So now between this interval of 2 to 6, right, on the interval of 2 to 6, when does the instantaneous rate of change equal the average rate of change? Well, we know the instantaneous rate of change before when we were writing this expression. We're basically saying f prime of c is equal to f of b minus f of a over b minus a. So we found this to be 12. Now, what is our f prime of c, right? Well, first we have to then find the derivative of our function. So the derivative of f of x, or f prime of x, is just 2x plus 4. So when does this the slope equal 12 for our function, is what we're trying to find. So we just simply solve this basic algebraic expression. 2x plus 4 equals 12. That gives us 2x is equal to 8, and our x is equal to 4. So at the point 4, which is between this interval, is on this interval of 2 to 6, our function will have a slope of 12. A slope of 12, which is the average rate of change for this interval for our function. So that's basically all we have to do with mean value theorem. It's describing a very fundamental concept that should hopefully make sense. Make sure that you're not, again, confusing mean value theorem with intermediate value theorem. I know the names sound somewhat similar, but they're describing very different concepts. So make sure you don't get those mixed up. But that's all we wanted to talk about in this video. If you found it helpful, please show your support by liking, subscribing, leave any comments. You leave any questions you may have in the comments, and I'll see you in the next video.